Welcome, and
welcome to the Astrophiz podcasts.
My name is Brendan O'Brien, and first of all, we would like to acknowledge Australia's first astronomers, the Aboriginal and Torres Strait Islander people, the traditional owners and custodians of the land we are on.
This episode is produced on Yorta Yorta and Kaurna country.
And we'd also like you to influence your local politicians to do more to mitigate climate change by moving from fossil fuels to renewable energy sources. Each month we produce 2 fabulous episodes. On the first of each month, Dr. Ian Astroblog Musgrave gives us his monthly sky guide, plus a unique astrophotography challenge and an astronomy tangent. Then, on the 15th of each month, we publish an interview with a leading astronomer, astrophysicist, space scientist, data scientist, telescope engineer, project manager, or particle physicist, and we discover their science journey and rare insights into how they think, when they think best, and how they conduct their amazing research into exactly how our universe works. Our audio files and transcripts are available on our website at astrophiz.com, and our MP3 files can be freely streamed or downloaded to your favourite device from our SoundCloud channel, our free Audible stream, YouTube podcasts and Apple podcasts.
But right now we're zooming over to Adelaide in South Australia to speak with Ian. Hello, Ian.
Hello, Brendan.
Great to be speaking with you again, Ian. And can you tell us what's up in the sky for the month of November?
Okay, Brendan, there's a lot of things going on. The planetary action is basically split between the morning skies and the evening skies, although there's lots of things happening in the evening skies. Mars is very low in the northwestern skies, and Mercury is putting on a good display before it disappears into the sun's glare. Saturn's still quite good to look at, and Jupiter's becoming more important in the morning sky. We've got 2 comets. Comet C/2023 R2 is high in the evening sky, visible in binoculars, and C/2025 A6 Lemmon will enter the evening sky early this month, but we can't really tell how visible it's going to be. We've got the Leonid Meteor shower also, but it's going to be kind of rubbish this year.
Oh.
Now, as always, I'll go through the moon. So November the 5th is the full moon. Now, this is a perigee full moon, which is usually hyped up as a supermoon. This is when the full moon and the moon's perigee occur at roughly the same time. It's going to be quite a nice one. So if you took photographs of the mini moon earlier on in this year and you compare them, you'll be able to see that they're quite different in size. November the 12th is the last quarter moon, which is good for stargazing in the evening as it'll be out of the way of the stars. November the 20th is the new moon, which is obviously also ideal for stargazing. Then on the November the 28th, there's the first quarter moon. And we can also see the lunar X, which is also on the 27th, just before the official first quarter moon. The moon will be relatively high in the sky, and so it'll be quite easy to pick up the lunar X if, for example, any of the cloud goes away. Moon's at perigee on November the 6th, which is just off the date of the actual full moon, and it's at apogee on November the 20th. So this is a mini new moon, but since you can't see the new moon, that's not going to be very exciting at all.
Okay.
So let's turn to some details for the evening sky. Mercury was putting on a good show in October. Unfortunately, so were the clouds. But Mercury climbs higher in the late evening twilight, early in the month. It comes close to Delta Scorpii in the head of the Scorpion on the 2nd. They're 1 degree apart. Then Mercury begins to fall back towards the horizon again, passing Mars on the 13th when the pair are 1 degree apart as it fades into the twilight. Now, Mars is still lowering in the northwestern evening sky, but because it's currently travelling east, it's not vanishing just yet. It is rather deep in the twilight, though. It's setting around an hour after sunset. It too is going to pass through the head of Scorpius. So on the 10th, it is close to the pair of Omega 1 and 2 Scorpii, which should look quite good in the sky. And then on the 13th, it'll be 1 degree from Mercury. At this time, Mercury is fading, so Mars and Mercury will be approximately the same brightness. Currently, Mercury is much brighter than Mars. Then on September the 21st, Mars is 4 degrees from the crescent moon, and it forms a triangle with the bright star Antares low in the twilight. Unfortunately, you'll need a level, unobstructed horizon like the desert or an ocean to see this, and probably you need binoculars as well to see Mars in the twilight. Now, if we turn north, Saturn is well past opposition, but it's still worthwhile viewing in telescopes. The rings are narrow and an interesting contrast to our usual view, but should be quite nicely bright towards the last part of the month. So at the beginning of the month, Saturn's its highest at an hour after astronomical twilight. So if you look to the north, it's the most obvious bright yellow object higher up above the horizon in an area otherwise devoid of bright stars. On the 2nd, if you're not too sure what bright object is Saturn, the waxing moon is about 3 degrees from Saturn. That's about 3 finger widths. And then again on September the 29th, the waxing moon is again 3 finger widths from Saturn.
Yep.
Now let's go on to the comets. Comets C/2025 R2 Swann is fading. It's currently around magnitude 5.6, so theoretically visible to the unaided eye, but because it's a rather extended object, it's really difficult to see. It's a worthwhile binocular object and photographic object in the early part of the month, as it's high in dark skies. It's currently in Aquarius and starts the month near Alpha Aquarii, so that's a very good guide start. But the waxing moon will make observation difficult after this, and up until the 10th, when the moon goes into its last quarter phase, and it may have faded to below binocular visibility by this time.
Yep.
Now on to C/2025 A6 Lemmon. That's been giving good displays in the northern hemisphere, and it's currently around about magnitude 4, which makes it reasonably visible to the unaided eye. It enters the evening twilight in the southern hemisphere from around the 3rd, but it remains low, and whether it becomes visible outside of binoculars in the twilight glow is uncertain. Even for those of you observing in binoculars, it's going to be low to the horizon murk by glometer, even though it's theoretically visible. Now, Jupiter enters the evening sky from about midnight on, but it's still best in the morning. For those of you who get excited by faint things, Uranus is at observation on the 21st of November at magnitude 5.7, again theoretically visible to the unaided eye under dark sky conditions, but it's still best in binoculars, and it's about 4 degrees. That's 2 binocular widths above the Pleiades, so it's relatively easy to find if you have an appropriate sky map. So that's the evening sky. There does appear to be quite a bit going on, though a lot of it is binocular viewing. So in the morning sky, the major action is Jupiter. Venus is lost in the twilight and basically won't be really visible at all until it goes back into conjunction and returns to the evening sky about mid-2026. But Jupiter is looking beautiful at the moment. It starts the month forming a battered line with Castor, Pollux and Procyon, and Jupiter is not far from the waning moon on the 11th. And if you're up early, you may want to get your telescopes out and have a look. It's going to be very good in the early morning. Now, the Leonid Meteor shower will peak on November the 18th to the 19th, and there's got good observing conditions. The new moon will be almost new, but sadly, tragically, it's not going to be a very good apparition this year, at least in the southern hemisphere. And you can expect a handful of meteors, and you have to get up about 3 to 4 o'clock in the morning to see maybe 1 or 2 meteors an hour. So not very exciting. T Corona Borealis still hasn't gone bang, and it's not visible this month. For the stars, Scorpius forms reversed question mark as it sinks into the western horizon. Sagittarius and with the center of the galaxy have departed from the zenith, and they've getting lower on the western horizon, but still worthwhile looking through binoculars at them. Orion, Canis Major, and the stars of Carina, Puppis, and Vela will begin to rise, and they'll be prominent in the late evening sky by the end of the month.
Yep.
At around about 10 p.m. local time, the Southern Cross will be almost due south in the sky. This means that most of the magnificent southern clusters and nebulas are sitting on the southern horizon, and so not really visible, even though the major stars of Canis and Puppis are rising. However, the Lesser Magellanic Cloud and in my opinion, the best globular cluster outside of Omega Centauri, 47 Tucana, are high in the south, and they're basically due south, and they're definitely to light. The much smaller globular cluster, NGC 362, is in the same binocular field, but may be hard to see unless you're in a dark sky area. Now, the faint constellation of Toucan celebrates the toucan of South American jungles. And in summer, you're going to definitely feel very South American sweaty as you watch these stars. Now, sweeping up with binoculars from 47 Tucana is the faint double star Lambda Tucana, and sweeping further up is the bright double star Beta Tucana. So there's lots to see.
Cool.
Then if you sweep east and down a little bit by the 3 binocular fields is the large Magellanic Cloud, the other dwarf galaxy of our own, and the iconic Tarantula Nebula is there to have a look. Now, while that's what's going on in November, and there's quite a lot, I'd like to briefly cover December and January, because as we're going to be going on a break for December, January, there's some things that you should be aware of. So on December the 5th, we've got another perigee full moon. Very nice. Jupiter's close to the moon on December the 7th. The Earth is at solstice on December the 22nd. And Saturn is close to the moon on December the 27th. Then in January, Earth is at perihelion on January the 4th. Regulus and the moon are very close on the morning of January the 7th. Jupiter is at opposition when it's biggest and brightest as seen from Earth on January the 10th. And it's a great time to get out the telescopes. And there's an occultation of Antares in the early morning on January the 15th at around about 4:30 a.m. So for those of you who are on holidays in December and January, the star guide that I gave you just a moment ago will help you navigate your dark skies when you're camping or out bushwalking. And there's also lots to see in the sky. Now, the Leonid Meteor shower on December the 14th is again one of our top meteor showers. Even though it's contending with a moon that is waning from last quarter, it's still going to be a very good year this year. So the peak is on December the 14th this year. And if you start looking between 3 a.m. and 5 a.m. in the morning, if you're in Darwin, you'll see around about 36 meteors an hour, which is pretty good. If you're in Brisbane and Perth, you'll see around about 23 meteors per hour. And if you're in southern Australia, Sydney, Adelaide, Canberra, Melbourne, you'll see somewhere in the order of 18 meteors an hour if you're in a dark sky side. Obviously, the further closer you're up to Darwin, so like Rockhampton, Kurranurra, Cairns and places like that, you'll see more meteors similar to Darwin. So even though we won't be on air for December and January, there's lots of good things to look out for. And just a reminder, the Geminids apparent radiant is just under Castor. So if you're up on at 3 o'clock on the 14th, you've got the Castor and Pollux twins the Geminids just under Castor, and then you've got Jupiter just above Pollux, making it a very lovely sight in the morning.
Very good, Ian. And do you have a astrophotography challenge for us for this month?
I recommend trying to get the Lunar X. Of course, the perigee full moon, if you've taken a photograph of the apogee full moon, it's a good time to take a photograph of the perigee full moon using the same exposure rate and same zoom factor as you did for the apogee full moon. If you haven't taken a photograph of the apogee full moon, take one anyway. Make sure you write down the zoom factor and your photography conditions, and then when the next apogee moon comes around next year, you'll be able to shoot the apogee moon under those same conditions and put the images side by side and have a look at how it's different. I might suggest trying to get the Comet R2 Swann, but it may turn out the light of the waxing moon is going to be a little bit too bright to get a really good image of it.
Fair enough, Ian. And do we have a tangent?
We do have a tangent, a little bit of a short tangent. You may remember in the September tangent I talked about the Comet Atlas, three-eye Atlas, the interstellar comet. So I'm going to talk about it again because even though we've got some really nice comets that are visible, Comet Atlas is a rare interstellar visitor. It's not visible to any of us amateurs because it's behind the sun at the moment. But despite all the good science that's being done, largely it's being promoted on the social media and the web in the crankosphere. So we're getting some really good information on the comet at the moment from the Mars orbiters. So the ESO Mars orbiter managed to get some decent images. And again, the Mars orbiters were not designed to image comets. They were designed to image Mars. And so they had to do a bit of fiddling around. But nonetheless, they've got some images of the comet passing Mars. Now that it's behind the sun, it's getting images from the SOHO coronagraphs, the CCOR1 coronagraph, and NASA's Punch spacecraft. And soon after it flies by its closest approach to the sun, the Jupiter Icy Moons Explorer JUICE will take some images as well. So despite all this, there's still claims that it's a spacecraft, not a comet. There was an article in the Daily Mail, which is not known for a large amount of accuracy, claiming that the comet was undergoing reverse thrust, so that it's a spacecraft that it was reversing its thrust. Not that it even makes any sense, but the data from the CCOR1 coronagraph shows that the comet is zooming along on its current trajectory. The dust and gas coma is progressing quite nicely, despite claims that there wasn't enough gas. Now that it's coming close to the sun, its gas production is becoming quite substantial now. There's some very nice data from the combined orbital spacecraft. Now, with all this really good information there, the crankosphere has been going into overdrive and you're getting lots of misinformation. So when the spacecraft were taking images, there was large numbers of images on social media saying, oh, here's the comet, and they faithfully circled the trailed star, completely ignoring the dim dot that was the comet towards the center of the field. And there's been a bunch of other things. For example, there's been what's claimed to be an animation of the comet going past, which was in fact a Photoshop of the Whale Galaxy, which is a nice extended galaxy. Very pretty, but it's not the comet. And the acme of misinformation came today when they showed an image of a paramecium That's a little ciliated microorganism swimming slide, claiming that was the comet. Yeah, yeah.
Classic.
So I mean, this is not the first time that we've seen these sorts of issues. The classic was back in Halley's Comet at the end of the 19th century, where people went into a panic about the Earth going through the tail of Halley's Comet. The cyanide in Halley's Comet was going to kill us all. It didn't, because after all, the comet's tail is a really good equivalent of a vacuum. Then Comet Leonid was going to cause massive earthquakes and tidal disruptions. And then Comet Leonid fell apart before it even got to the sun. And then suddenly we didn't hear anything about that anymore. Comet Ison was the same, earthquakes, meteor showers. And then Comet Ison also disintegrated before it got to the sun. And then McNaught's comets, which came very close to Mars, was going to smash into Mars and cause all sorts of problems on Earth with debris from Mars. And it didn't. It was quite a nice little comet, but it didn't do anything exciting. And this raises the question, why do people want these dramatic things or get these dramatic things?
Oh, look, I can't answer that, Ian.
Yeah, I mean, we've gone from Elenin and Ison hiding the planet Nibiru or a giant mass object, which they patently didn't. I think I mentioned this before, that one of my own photographs was taken to claim that Ison was being followed by a massive object, when all they'd done was glued a photograph of a crescent moon onto one of my comet images that had nothing to do with Comet Ison. And it's tempting to laugh at these things because they're obviously silly. But in the case of Comet Ison, a person committed suicide because they thought the Earth was doomed because of this massive object that was supposed to be trailing Comet Ison, which was completely imaginary. Again, because people think this is not important, they don't. The effort into explaining why these things are not real tends to be put aside. The number of articles that have gone into debunking this is not a spacecraft are minute compared to the number of articles saying this is a spacecraft. I know it's overwhelming. Social media is full of rubbish at the moment, from flat earthers to anti-vaccinationists to a whole range of weird and wonderful stuff. But things like this, it shows where our lack of understanding of the world comes from. I've mentioned this before in the context of people who mistook the moon for a UFO, who mistaken Venus for a flare or a landing aircraft, or the massive drone panic that happened last year in the US and more recently now in Denmark, where people were looking at ordinary aircraft and in a couple of cases stars and the planet Jupiter. We don't look at the night sky anymore. We don't look at our environment anymore. People are panicking over clouds, thinking that they're being sprayed with toxic chemicals, looking at ordinary every night and day mackerel skies. Science literacy and sky literacy is absolutely critical. The number of people who are in a panic because they don't understand the sky or what it looks like is large, and we have to do something about that. And there's only so much outreach you can do as you get overwhelmed, but we still have to try and explain these things and to show how there's so many wonderful things in the sky for real that we don't need to make up interstellar spacecraft.
Exactly, Ian. And that's exactly what you're doing here, Ian, improving sky literacy with your outreach. Well, thank you very much, Ian Astroblog Musgrave. November is great, and you've given us a preview of what's up in the sky for December and January. We'll see you back in 2026. And in the meantime, I've got a couple of very nice episodes coming up. We've got an interview with Dylan Griggs over in Western Australia, and he's going to tell us about the unintended frequencies leaking out of all the constellations of satellites. There's going to be 30 or 40,000 of them up there very soon, which can interfere with the arrays of radio telescopes we've got. And then we've got another interview coming up from Dr. Laura Hayes over in Ireland, and she's a solar physicist, and she's got some amazing stories about the sun and how it's hurling some amazing packages at us on Earth. So we've got a couple of really nice interviews coming up, and we'll see you back in 2026. Thank you, Ian.
Thank you, Brendan, for having me on and helping people look at the sky. And I'll be looking forward to coming back and chatting about the sky in 2026.
Excellent. Good night, mate.
Good night, mate. All the best. We'll see you in the near future.
And remember, Astrophiz is free, no ads, and unsponsored. But we always recommend that you check out Dr. Ian Musgrave's Astroblogger website to find out what's up in the night sky. And our next episode, coming soon as I finish the edit, features Dylan Grigg, a fabulous PhD from Perth in Western Australia. Dylan has been doing amazing work that impacts on the effectiveness of every radio telescope on the planet, all the individual ones and all the arrays. He has revealed the presence of unintended radio frequencies leaking from the tens of thousands of low Earth orbit satellites above us, and these leaking frequencies are threatening to drown out the very faintest of frequencies that tell us what was happening at the very dawn of time. This is important work, and it was great to speak with Dylan. You'll love his stories. See you soon. Keep looking up.
Radio Wave!